You're listening to the WB Download, coming to you from Wheel & Builder's showroom in Studio 1C. We are a podcast centered around building custom homes, the customer experience of building a custom home, and a really entertaining listen from many great guests and interviews that may or may not have anything to do with building. I'm excited to share with you their voice and their stories that will enhance your idea of the custom builder world. Well, hello again, everybody. This is Jeff Whelan here on the WB Download, coming to you from Wheel & Builder's showroom here in Westchester, Ohio. Today is Tuesday, May 28th, and welcome back to the show. Thanks for listening to us. You know what? Today, in the last couple of weeks, we've had a lot of things going on. We just got Memorial Day behind us. The last day of school is upon us, and summer is here. So, man, I'm telling you, it's been some decent weather. We've had a lot of rain, but some good things happening. Things are looking good. Thankfully. So we've been really busy with things going on around here. We've got some really good deals happening. A lot of people we're talking to, just really cool houses, cool people. And man, I'm just so grateful. I have to credit to our staff and to the people working here for so many great things happening. So it's pretty cool. As always, I give you an update on our Homerama house. Right now we're in the middle of doing a lot of different things. We're finishing hardwood in there this week. And so it was a big step for us getting that kind of finished up. We do a lot of things where we're starting and stopping. So right now, we've been finishing up some metal roofing on the front and back of the house. And what I mean by starting and stopping is the outside trim guys come in there and they do some work, and then they got to stop, and we got to get some flashing on for the metal roofing. And then I got to come back, and then we got to come back and do the metal roofing later, because there's exterior trim above the metal roofing, and I don't want the exterior trim guys and the painters standing on a metal roof trying to do their work because it gets destroyed. So we start and stop. We had to stop laying some brick until the porches got poured, and then we came back in and finished up some columns and some arches and some fireplaces and some things like that. So it's a start and stop kind of thing. And so that house is it's beautiful, and it's coming along good. So we just closed a few more houses, and we closed this awesome house and we closed a couple awesome houses. Man, they closed them in different places, but I was taking some pictures the other day, and this is how funny things I think are cool and things kids don't think are cool. But we have an inverted valley that comes into this house, and it's in the second floor, right above a loft. It overlooks this huge stairwell, and I'm sure you'll be able to see pictures on our website and our social media. But I was showing pictures to my wife Shannon, and I'm showing pictures to my son, and my son goes, "What's so cool about it? I don't get it." And I'm like, man, you got a long way to go, son. But not everybody thinks it's as cool as I do. But anyway, things on the farm right now. We just moved the cows all out to summer pasture. Everybody's bred except for one cow, and we're getting ready to haul her in and move her on because she's not operating properly. And the other thing that we're happening is I want to say happy birthday to Jack Ryan, our own Jack Ryan. He's our job site assistant. His birthday is this week, and we're going to celebrate with him coming up here. So anyway, today I want to talk about energy efficiency in these homes. So what do we think about when we think about energy efficiency? So I think most people think about geothermal. They think about insulation values, or they think about energy bills. How much is it energy efficiency going to save money for me? And can you save that money in the long run on spending money up front on these features? It costs money to save the earth. So if you're doing all these energy efficiency things to save the earth, you're going to be disappointed because it's going to cost you a lot of money. But anyway, for real, let's talk about the framing. And so, energy efficiency in these houses, anything most people would consider 2x6 versus 2x4, that a 2x6 wall is going to be more efficient. I agree. 100%. You can get more insulation value in that wall, in that 2x6 wall. Even if it's 16 inches on center stud spacing, you get more insulation behind the electrical outlets, the switches. You get more insulation behind the wires running through the wall. It gives you more room to provide more insulation value in the entire cavity. One thing that a lot of people do is they'll run 2x6 walls, 2 foot on center instead of 16 inches on center. And that's all great because you're going to get a more efficient house because you have less wood members. Wood has a lesser R value than the insulation does. But when you do that, you have fewer structural members in that wall. And so that I don't, that's the part that I don't like about it. But definitely 2x6 is the way to go. But because of, not just because of the thickness and the more wood is a stronger house, but because of those different barriers that you can get in there, variables that you can get things in there in that stud space. The other thing that we want to think about is when we come to the corners of our framing, we do what we call a California corner, which is a lath and allowing that wall to continue on past the T-wall. And what that does is allows us to tuck insulation in between that corner. You can't solid member those corners thinking it's going to be stronger and it's going to brace itself off. You have to allow some blocking in there and allow that insulation to continue on in those corners. Things you don't think about, but it's very, very important. The other thing that when we're talking about insulation, when we're talking about wall cavities, we talk about the insulation, and the insulation is, it's an R value. In a 2x6 wall, you can go up to an R19 R value on a craft back fiberglass insulation. Then you can get into an open cell, closed cell foam insulation, sprayed in foam insulation that you could do in there, or you could do a partial spray foam and a partial batt insulation. You can do all sorts of things to that wall cavity to increase your insulation value in there. Again, it becomes how much money do you want to spend in order to achieve a certain rating? What type of rating are you trying to achieve? And all of these ratings are great, but ultimately it comes down to the indoor air quality on the inside of the house. What are you trying to achieve with this? Or if you're just trying to achieve lower monthly bills, then you need to think about things in a different light. How that's going to affect your system, and all of these things. Lower monthly bills are going to take everything into account on that I'm going to talk about today. So the other, on the insulation, on the framing, we go through a number of different inspections to get this improved. Anything that you will read when you go to Energy Star's website, when you think about lead performance and all these things, it's not just about the equipment, not just about the insulation, not just about the materials you're using. It's about the labor installing these things. If you have somebody who doesn't know why or how to install insulation, it's going to be a mess, and you're not going to get the performance out of any of these things that you thought you were going to. You might pay a lot of money for the material, and you did, and then maybe the builder didn't pay, or you didn't pay enough money for the labor to install it, and you're going to be disappointed. And then naturally people are going to blame the product, and that's not the way it should go. So then let's talk about on the outside of the wall, we're going to talk about air barriers. And air barriers, or some people call it weather barriers, they come in a couple different ways. They come in a paper product, which comes in a roll, like most people are familiar with Tyvek. And then they have liquid applied barriers, which is like a zip wall or an EnviroDry. The Tyvek goes up on the outside. It's a paper, goes on a roll. The best way to do that, in my opinion, is to wait till the house is completely built. Pay some guys who that's all they do is install Tyvek to come out, install it all the way around the house, and make it continuous. So you're not building a wall, putting a Tyvek on it, and then building another wall, putting Tyvek on it, and taping it together. It doesn't work very well that way. And then in the zip wall product is a factory applied liquid air barrier. So it comes out, it's green, says zip on it, and it's on the actual OSB plywood as it arrives on the job site. And then you put it up, you put it up right directly on the framed wall, and then you tape all the joints and all the seams as you put it on there. And then the liquid applied air barrier, which is EnviroDry, is what we use. And the reason why we use it is because you're using more of it, and it's really, really helps our energy efficiency ratings. But what I mean by using more of it is that on all the joints that are taped with a mesh tape, and everything gets sealed with the EnviroDry, as opposed to Tyvek that has a solid tape that tapes all the joints. When it tears, when you go up to a gable, when you're putting the two pieces together, it only comes in 9-foot rolls or whatever it may be. You have to tape all those joints. When you have penetrations come out through the outside of it, it gets torn. It has to be taped, if it even gets taped. And then on the zip wall, same thing. You have to tape all the joints. You have to seal all the nails. that go through there, and it becomes less and less usage on the total square area. The positives and negatives, I just talked about a couple of them. They're all a pain in the butt. I could tell you that. As far as expenses, the Tyvek, or that paper barrier, is the least expensive. The EnviroDry is the next most expensive, and then the Zip is most expensive for us. And the pain in the butt about all of them, the Tyvek, you have to put it on, instead of just continuing to frame the house, you have to put it on. And the Zip is already on there, but then you have to seal all the joints with tape. You have to roll. It's got a little zip roller that you have to roll it on there, make sure that they can see the little Z in the tape. And then you have to have somebody come back and sit there and take this caulking or this tar and seal up all of the nail holes around the whole thing. And in the EnviroDry, it's weather dependent, and because it's applied out in the field, if the wind's blowing, that stuff it's a tar basically that you're spraying all over the place, and it carries. If there's cars around there, if there's any finished product around there, it gets destroyed. And then if it's raining or it's too cold or whatever the case may be, it makes it pretty tough to install that stuff. So those are the air barriers. And then jumping back to the interior of the wall, you want to make sure that you're sealing up the joint between the subfloor and the wall. You're sealing up, if you have multiple studs put together, you're sealing up each one of those with the caulking. You're sealing around your windows. We use a spray foam insulation that goes around your windows to seal up that whole joint in there, instead of trying to cram insulation in there. And then you're flashing the outside of the windows. And then you're flashing also at the bottom of the wall coming down to the foundation, making sure that you're creating a brick ledge there or whatever it can be. But when you get to the bottom of that wall, framed wall, subfloor, and foundation, there's a bunch of joints there that need to be sealed up. So you're going to make sure you flash that as well. Thinking about R values and thinking about types of insulation. I think I mentioned this before. When I first started building, we were just using insulation without a craft back on it, without an air barrier or vapor barrier on the back of it. And we would just put it in the wall space, and then we would take a 4 mil clear plastic and we would wrap the inside of the house, which is crazy because it's 100% the opposite of what we do now. And I think what we do now makes more sense. It allows the air to travel back and forth and allows the moisture out, but doesn't allow the moisture in. Those are some really important parts to what we do there. So that's the thermal enclosure of the system. So the other thing that we want to talk about is reduced thermal bridging. And so when you have an exterior wall, and people, the same thing with sound insulation. Sound is transferred not through the gaps or through the cavities, but through the members touching each other. So if you have a stud and you have plywood on the outside of the house that's connected with a nail, you have drywall on the inside that's connected with a nail, the cold air, the warm air, the sound, everything transfers through those connected points, not necessarily through the wall cavity. It's easy to insulate that wall cavity. It's harder to insulate that stud space or stud area. One of the cool things that Zip offers is a insulated panel. So they have a 1 inch, or I think it's a 1/2 inch panel. They have a 1 inch panel, and they have an 1.5 inch or a 2 inch panel. Really cool stuff. And the thing that this does is it allows for a continuous insulation going all the way around the house. So right now, without that, we have a stud, and then we have a stud space with insulation in it. We have a stud and stud space. With this insulation board on the outside of it, it's continuous insulation board. It does that. It breaks that thermal bridge that goes between each one of those, and just makes for a heck of a lot more of an efficient wall structure. And then, when we think about reducing that thermal bridging in the house, the labor, and again, you're not talking about the insulation itself. You're talking about proper installed insulation. You're talking about your windows. Use a high performance window. Great. Use somebody who knows what they're doing to install the windows. It's very, very, very important. All of those things for that wall cavity. Same thing up in the attic. When we think about the attic insulation, because again, as the heat rises and everything comes up there, as those shingles are up on the roof, that attic gets so super hot. It's very important to have proper ventilation in the attic to make sure that hot air is escaping out there. Because if that hot air is stuck in there and it's forcing itself to come down through that drywall on the second floor or on that ranch ceiling, then it's going to make your house hotter. It's going to make your house inefficient. And so that's really important, is to make sure that attic space is vented properly, and then making sure that you have the right insulation up in the attic. And you can do, in Southwest Ohio, an R30 is blown fiberglass insulation is probably the minimum that you can do. I mean, right now we're doing an R40, or 49, I guess I should say, in those attic spaces. And that's a matter of the thickness that it's blown in up there. And so many other parts of that are important. So let's talk about your heating and cooling system and what makes this efficient. Well, the equipment itself, let's talk about that. The heating and cooling system, if you have a Train furnace or a Carrier furnace or a Goodman furnace or all this different equipment, and it's no different in Ford versus Chevy versus Toyota. Everybody loves everything for a certain reason. And I think that pretty much warranties are all the same, which is something I really worry about, is making sure that the warranties are there and they're good. But again, the installation of this equipment, and it's so important. The design of it and the installation of it. So when we talk about the design, it's not just about the equipment. So you can't say, I got to use Train. I got this great Train furnace in there, and that's why my house is operating so great. No, it's not. You had a good person that designed it. They ran a manual J and a manual F, which is the sizing of the supply, the direction of the supply lines, the vents that go up through the floor, come down through the ceiling, the size of those, the location of those. Did you have a guy that just put it in there and they all ended up underneath doors and beds and furniture around the outside of the house or outside of the room? Yeah, that room's going to operate horrible. So you need to think about those things. They put ventilation in the closet and it's all underneath the clothes. Doesn't make sense. And the return air is equally as important as the supply air. So the manual J and that manual F tell these guys the type of the tonnage of the system, the size of the equipment, and then where they're going to run this stuff. The heating and cooling system runs on less resistance. The less resistance that it has, the more efficient it is. The location of the furnace in the basement, you want to make sure that it's in the centrally located area of the basement, that it's not, you don't have 100 and something foot wide house and you have a furnace all the way on one side, forcing the air to go to the other side. That doesn't make sense. So again, not a lot of that has to do with just the equipment. It has to do with the person installing it, designing it, and making sure that they know what they're doing. The ductwork has to be properly sealed. And we use, again, a liquid applied sealer. We're not using this foil tape or whatever it is. We want to make sure that the whole thing is sealed up. And this is on the outside of the ductwork. It's like a gray, pasty looking stuff that seals everything up. There are some interior sealants that you can put in there. And basically when these guys are done with the system, installing it, they run this, it's almost like an air glue. And they're doing this with houses now too, but it goes inside the system and seals up anything from the inside out, which is pretty cool stuff. But it's also expensive. And then with this heating and air conditioning system, we're talking about the indoor air quality. And so you have to consider the ventilation for it and how the house is vented. And so when we think about ventilation, cold air returns are one of them, but then the ventilation through mechanical ventilation, you can think about the air filters that you're putting in there. Air filters are measured by what they call a MERV, the MERV, and forgive me, but I can't remember what that stands for. I had it written down and I lost it, and I'm just losing my mind today. But forgive me. Anyway, it's a MERV, and it's a MERV 6 or higher is what you want on those air filters. Some people, I have some guys believe that you want less resistance on that air filter because you want it to catch some particles, but you still want the air to flow. Other guys believe that this MERV filter needs to be protecting the house and the indoor air quality. I believe the latter of the two, and make sure you're protecting that with a good filter system. Make sure you change your filters at least once a month. If you just move in, change them every 2 weeks. It's very important. And as we're building these houses, we're changing them all the time because that air that's coming through there, we want to make sure that it's not affecting the system in a negative way. We use steel ductwork. Running the direction of the ductwork and how it's run down through there is very important. And then we also try and resist the flex ductwork when we don't need it. Now, if we're up in an attic and we're spanning off, we use the flex ductwork because it's insulated. But you want that path of least resistance to make your heating and air conditioning more efficient. So think about indoor air qualities. You want to think about the fresh air system on your house, the ventilation on your kitchen and bath. You want to think about the MERV 6 filters. You want to think about the air sealed walls and all of those things that go along there. When I think about the filtration, again, I just talked about that and harped on that, but that's a big part of how your house is going to operate. You want to put an air cleaner on there. You want to put a number of different things on there. The other thing to think about when you think about indoor air quality, and this doesn't have a lot to do with efficiency, but make sure you have a humidifier on there or a dehumidifier. I like a humidifier on there in Southwest Ohio because we need a certain amount of humidity in that house to control the way the trim is, the way the floors are, the way you feel in there. A lot of that all has to do with the moisture and humidity that's in the air, because if you don't have that, then you'll start to realize that and you're not going to be happy living in there. These things will create problems for you that you don't know that you have. And that's really, really tough. So thinking about that, you want to think about the indoor air quality protections. And you want to think about carbon monoxide. You want to think about nitrogen dioxide. You want to think about pests. You want to think about things coming from the outside to the inside, mold. You want to think about all those different kind of things. And so when we cover a lot of these things we just talked about, that will protect you against a lot of those things. You've got to have a conscious builder. You've got to have a conscious installer to consider all these things, that you can't just come in and say, it's time to put the insulation in, and they call the insulation guy. He comes out and puts it in, and then you call you for your inspection and you move on. You got to have a conscience when you're putting these things together. So let's think about the a water management system, or the efficiency of water in your house, because let's not forget that, again, we talk about the energy efficiency bills. You're getting a bill from Duke. You're getting a bill from your energy supplier, I guess I should say. But you're also getting a bill from your water company. And what does that look like? How does that control what you're doing inside this house? Water, for the most part, is fairly inexpensive, but it's, again, an expense that you do have. Let's think about So energy efficiency, and you get into LEED certification, you think about how your home takes the storm water and what you do with that. You want to make sure that it's getting away from the house as much as possible, but you can also do things that will collect that rain runoff water and make sure that it's in there. But the reason why you want to make sure that you get it away from the house, anytime I've ever been called out to a job to do, because I'm an expert witness on trial cases for builders, and I'll go out and they'll say, hey, they had a leaky basement. The first thing I look at is the gutters. Are the gutters covered? Are they filled with crap? Is the water running directly over top of the gutter, coming down and hitting the house and then running up against the foundation? Does the foundation, the backfill on the foundation on the outside, does it have positive drainage running away from the house? If any of these things are in the negative, then that creates an opportunity for water intrusion into the house. It creates a horrible indoor air system. It creates a problem with the water management system on the outside of your house, and it starts to become a water management system on the inside of your house. So you want to consider that. You want to consider the waterproofing material that's on the outside of the house, and all of those things take a toll on the indoor air the indoor quality of your house. You want to think about water usage, and let's think about your toilets and your faucets. And people complain about pressure, I think a lot of times, which is, we have a pressure regulator on the house, because if you just ran full pressure coming from the city or coming from your well, and these faucets and everything are designed to run at a certain pressure. If it's too much, then the life of your faucet will fall apart. And you say, well, the faucet has a warranty on it. The first thing these guys are going to do is check your water pressure, and if it's too much, then they're not going to cover it. But they have to operate at a certain gallon per minute. And so a lot of these, and when we do LEED certified houses, this is a requirement. But your commode will have 2 buttons on it. It'll have a big button and a small button. And I asked the first question I said, what's the difference? And they said, well, it goes along with how you go to the bathroom. If it's a big one, you hit the big button. If it's a small one, you hit the small button. And so it's crazy to think like that, but it's true. So the most common would be use a small button. You're using less water. You're using less of the sewer system, et cetera, but you're using less water. All of these things, your faucets in there, they want you using less water. I think that we all would be okay if you had the same amount of pressure, but you were using less water, you wouldn't care. And this has all been designed over time, and I don't think it bothers people as much, but that's another thing that we consider. And these are all things that are made by manufacturers, and they're not something that you have to necessarily worry about how you're operating in your house. It's already installed in your fixture from your manufacturer. So let's talk about moving on to the next thing. We've been through the wall cavities, insulation. We've been through heating and air conditioning. We just talked about plumbing, and I know these things are brief, but I don't want to bore you, but I want to spark your interest to go on and God forbid you go on the website and start looking around on Google and start Googling things, because you'll get inundated with things that are, it's a black hole. And you can keep going and going and going. I think the safest place to go is the Energy Star website, and they will kind of guide you in a direction in which you can understand things. It explains things to you a little bit easier. Instead of, the other thing you don't want to do is get hung up on a site that a manufacturer is backing or a manufacturer is pushing, and you've heard me talk on here before how the building code's so jacked up because of manufacturers pushing their product. Is you don't want anything like that, because then you're going to end up with something that's unneeded. Go to somewhere that's an independent site that's going to explain to you what you need. So anyway, let's talk about lighting and appliances. And appliances, I can't tell you what's efficient and what's inefficient about those things. Most of every single one of them I've seen, they have an Energy Star sticker on them. They understand that your refrigerator, your washer and dryer, I would imagine your refrigerator is insulated a certain way. It operates on so much electricity, and that's what gets its energy to that point. Your stove, uses less electric to get up to the temperature that it needs quicker, instead of sitting there running for a long time. Your washer and dryer will use less gallons per minute, and can operate at a lower efficiency on those things. That's what I would think about when I think about my appliances. Your vent hood in your kitchen is going to be directly in relation to how much ventilation in the area of the kitchen, and also the size of your cooktop, in order to get the moisture and get everything out of there. One of the things we run into quite a bit is that we use these huge ovens. They're 48 inches, 60 inches wide. So we have to put a 10 inch or a 12 inch or even a double duct in there with this huge commercial hood. And when we do that, we have to do what we call makeup air on the furnace in order to bring more air, because it'll suck the drywall off the walls if you keep running that thing. So we have to put in a makeup air system on the heating and air conditioning system to allow for that great big ventilation ductwork taking the air out of the house, which means that we're taking so much air out of the house. This makeup air is bringing more air into the house, changing that out. So lighting efficiencies, the easiest part to explain to this is the light bulbs. We use LED light bulbs, and if you want to get in miserable condition, go to Lowe's or Home Depot or somewhere and try and buy a light bulb. I just need a light bulb. Oh my gosh. I matching them up to the ones that we have now that look the same. Like they have a white light, they look a yellow light, they have daylight, they have all this crap. And oh my gosh, it's horrible trying to pick these bulbs out. I end up spending more money in bulbs because only because I get home and it's not the same color. I get back to the office and it's not the same color. It's not putting off the same light as what is already there. So that's something to consider, is the color that you want, but also the efficiency of the bulbs. And of course with these LED lights, they last longer. They want you to get the bulbs that last longer because you're not throwing them away. They're not making more. And that creates somewhat of a energy efficiency list. The safety and reliability of these bulbs, since the LEDs don't get super hot, people aren't burning themselves on the bulbs anymore. And that makes it a lot better for everybody. Another thing I was thinking about is your dishwasher too. I mean, your dishwasher is using less energy, but it's also using less water, which is odd because, I remember back in the day, a dishwasher would run for 20 minutes, clean the dishes, take them out. Now our dishwasher runs for, I think, 2.5 hours for the most part on those things, and you get them out and I still have to dry them all off, which is special. But that's enough to drive you crazy. And so those are the high points of energy efficiency. Now, when you talk to my friend Dan Geis out in Golden, Colorado, and he's talking about building an energy efficient house, you can talk to AFT Construction, Brad Levitt out in Arizona. He was on our podcast before talking about energy efficiency building. These guys know what they're talking about, and they build these crazy, super efficient houses, and they do all these different testing, and they use these specific materials that go along with this energy efficiency. It's so much more than what we do here because they're both in different extremes. In Southwest Ohio, what we have to deal with most of the time when we're talking about air quality is the fact that our temperatures change sometimes 50 degrees in one day, and that's pretty close to it. When you're coming out of winter, coming into spring, that's a big change. When you're coming into out of fall into winter, that's a big change per day. In Arizona, they've already had over 100-degree days out there. And in Colorado, you're dealing with snow loads, and you're dealing with a lot of wind, and you're dealing with a lot of different things. Just from Cincinnati to Cleveland, I have friends of mine that build in Cleveland, and they're up there on the lake. Their frost line is 12 inches deeper than ours is. They have to build with different straps and structural mechanisms to hold the house together because of the lake effect. They have different installations. They have different requirements. All of these things change the way your house operates and change what you need for energy efficiency. So it's something to pay attention to. This is not something that we get crazy about here at Wheel and Builders because we do so much of it kind of standard. But if there's always another level to get to, and we built a handful of these lead projects, and that's probably a whole nother episode to have a lead energy rater on here to talk about the things that we do. The first time I got into those meetings, I was just amazed at the people who we were sitting in there being led by because of the information and knowledge that they have on these things and how we would build. And a lot of it's common sense. And I'm like, well, why don't we do that already? Well, I think we do, but I'm not double checking it. I'm not splitting insulation to go around wires, and I wasn't spray foaming behind outlet plates or behind switch boxes. And I'm like, man, this makes a lot of sense. And so we do a lot of those things standard now. But energy efficiency is really important. So I hope this was enlightening to some of you. I'm positive I'm going to get some feedback on this for people to say, you should have said this and you should have said that. And let's talk more about it. I hope that people call me up and say, hey, you should have talked about this. And I'm going to say, hey, why don't you come on the show so we can talk more about it, because this is not a never ending subject. So right now I'm interested because right now we have a house going on up in Liberty Township that's going to have solar, it's going to have geothermal, and it's going to have propane backup, and it's got a lot of different things going on up there. And we're going to talk about insulation with those guys here shortly. We have another house in Liberty Township that had spray foam insulation and it had geothermal in it. And I'm looking at some of their bills. We have another house up in Mainville that had the 2-inch insulation board on top of the zip wall and had 12-inch foundation walls and had all these different things going on with it that were super energy efficient, super conscious about energy. And I'm looking at his bills too. We talk about these things. So I'm interested to take some of that, those results and have an episode about that and talk about the things we did with those houses specifically to get to that point. And hopefully you guys would find that interesting. So, hey, thanks again, everybody, for listening to the WB download here. I would just want to remind you that our episodes come out on the second and fourth Tuesday of every month. And if you want to subscribe to the WB download, please make it your favorite podcast. And you can get that on Apple, Google, and pretty much anywhere you get your podcast needs at. And if you want to be part of the conversation, email me at wbdownload@wielandbuilders.com or go to our website, wielandbuilders.com. It's WIELAND builders.com. And my last name is Wieland, not Weiland. Hey, thanks again, everybody, for listening. Happy that you're here, and have a great couple weeks. I'm Jeff Wieland.